Hello again and welcome. A few weeks ago I made the announcement that I'd closed my Github account. There's a few reasons for that. A lot of people seem to find Github very confusing to use. Actually, I had one person who wrote me who claimed that the view that they were seeing didn't match at all with what I was showing, and then come to find out they were using their cell phone on GitHub. So this gives you some idea of what I'm dealing with when I try to distribute this software. One of the more common problems is people didn't understand the span zip file. So of course with GitHub, the reason I used the span zip is they had a file size limitation, so the only choice I had was to split up the installer. A lot of people didn't even use the installer. They just went to National Instruments and they started downloading various runtimes. Of course they would go to the latest one, and I'm using an old copy of LabVIEW, and they would find out that didn't work, so a lot of them would just randomly try stuff, and then they would write me how it wouldn't work. Another common problem is people would try to install it and then they wouldn't install the VISA. Of course, that VISA layer is how the software communicates with the hardware. So anyway, my plan is to change over to Dropbox. So this is what it looks like if you log on to it. Of course, you could copy and paste the link out of a screenshot, but I'll go ahead and provide a link to the Dropbox in the description. One directory is for the original Nano VNA. Let's just look at that. So you can see there's a calibration, a crystals directory, a data directory. Here's the actual executable. Again, these files are what were available up on GitHub, so none of this has changed. Let's go back up to the root directory under NI runtime. This is the LabVIEW runtime for 2011, Service Pack 1. Here we have the runtime engine for 20.1.1, and of course NI VISA. So if you want to run my software that supports the older Nano VNA, like the H or the H4, you'd have to download this runtime engine 2011 as well as NI VISA. Again, I'm only supporting Windows 10 and newer. If you want to run something older, you certainly can, but you'd probably have to download an older copy of NI VISA to pull that off. Again, I've ran that software on Windows XP without any problem. It is a 32-bit program. Now in the future, I have no plans on supporting that older version of software. If we look under Solver64, if we open up the README file, this is the change log. So this is all of the changes that I've made up till the current release. If I just go back to the root directory, what you can do with this is just hit download. This will download all of the files. You can see VNA support.zip. And this file will contain everything that I've uploaded into the repository. You can also, again, just do that like from the Solver64 directory. This would download all the files contained inside this directory. So hopefully you find this easier to use. I don't know if it would work with your cell phone or not. Hopefully people that are at that level would realize that, the software isn't going to support running on a cell phone anyway. So about a year ago when I released Solver64 initially, I had actually bought an upgrade license for home, and that's what I had planned on using. And of course, National Instruments had changed their licensing agreement where it was no longer a perpetual license, but rather a rental. And the cost to maintain that would have been very expensive. So once I discovered that, I'd ended up contacting NI, and I canceled my subscription, and they refunded my money, no problem. But after a year had gone by, National Instruments, or NI, started contacting me, reminding me to update my subscription. They went so far as to send me an invoice in the mail for it. So after the second friendly reminder phone call, the third one was a little more aggressive. They went so far as to make threats that they would disable my software. Of course, we were very clear to them that we had removed all the rental software already, and that NI had already reimbursed us. So the only thing that I was using was my perpetual licenses, and good luck disabling that because that's going to end up in a lawsuit. One of the things that's been happening at NI, of course, Emerson has announced a buyout. One of the things that we're curious about is if National Instruments had overstated their earnings or their value per se, basically to pump up their numbers to make it look more attractive to Emerson. I don't know if that's what happened. After that third phone call, they haven't contacted me since. One of the things I want to be clear about is I have not updated the manual. I have no plans on updating this because essentially people didn't read it. So I wasted a lot of time answering questions that were covered by the manual, so I don't really see any value in updating this. So let me go ahead and bring up the software. Again, it's called Solver64. And again, it's just looking for the defaults file. I'll go ahead and load this up. Now again, at the top of the program, you can see this supports the light VNA. It also supports the V2+4, sort of. So the V2+4, this guy here, I bought this quite a few years ago prior to buying the light VNA. From what I understand, one of the problems with this is that they had locked down the firmware development. So the firmware for the light VNA, which is currently developed by a person by the name of Dislord, has continued to upgrade this firmware. Essentially, this has fallen far behind, and my software makes use of a lot of the features that he's added to this firmware. So while my software probably still does work with the V2+4, it certainly isn't going to provide all the features that the light VNA would. Now, OWO, the person who had developed the hardware for this, they have a couple of group I/O reflector sites set up. I've tried to join those off and on. I was recently reminded how much they censor the posts on that. I had rejoined to answer some responses about a transient protection module that I'd made. There was a feeding frenzy from the hams who I don't even think watched the video on that, but they were talking about how that circuit would never work. Anyway, I tried to respond to some of those posts, and unfortunately OWO was censoring all my posts. I think they censored 50% of my posts at that point. I tried to redirect them over to the EEVBLOG, but unfortunately they censored that post as well. One of the things I had noticed when I joined was that OWO had released a new VNA. It's called the VNA 6000. There's a -B model they claim has 110 dB dynamic range. Now, if you read the fine print, they talk about doing 10 averages to achieve that. Yeah, it's kind of funny because you read their site and they talk about the clone guys all doing all this averaging to hit these numbers, and here they're pretty upfront that they're doing averaging to achieve that dynamic range. As slow as these things are already, I would imagine 10 times averages, it's really going to slow this thing down. I thought about joining that group. A lot of people are asking the same questions. Where's the reviews? OWO doesn't seem to respond to any questions that the group has. I don't know. It's $1,500 just to try it. I wouldn't recommend it. If it really does have 110 dB dynamic range and Dislord is actually doing the firmware for it, maybe it's a good deal. Certainly if it can do 110 dB at 50 kilohertz, that's going to be better than what I could do with the original Nano VNA. I don't know if it can do that or not. One of the things I noticed that OWO had posted is that they changed the hardware design where this thing uses a modulation to reduce the cost, I guess, of the hardware. The new one, the 6000 Plus, doesn't do that. And the big advantage to that is going to be that that new hardware can actually do narrowband measurements. Again, they had released a version of the V2+4 that they called the Pro version, and they claimed that that could do narrowband measurements. I think that that was just a firmware change, kind of like what Dislord had done with a light VNA, trying to filter that thing out. For me, that personally really doesn't add any value. I'd rather just use the original Nano VNA. It would do those measurements much faster. So again, I would still say if you're working below 300 megahertz, the original Nano VNA, like the -H, maybe the H4, may be a better choice for you. But if you want to work above 300 megahertz, I still like the light VNA. It's about $120, I think. This particular one is the latest version of the hardware. I think this one has about 5 dB more dynamic range than the original light VNA. So a couple of things about this 4.0 software. First thing is it's going to require a new defaults file. If we go over to Setup Diagnostics, basically what you're going to do is set this thing up the way that you want it. So set up all your COM ports and then hit Save Setup, and the next time you run it, it's going to set up all those defaults automatically for you. I actually had somebody write me once and they were saying that my software was having all these issues. I don't know really what they were trying to do with the software, but the software is trying to communicate with the M drive motors. So of course those M drives, if you don't have those attached, the software isn't going to be able to communicate with it. What you want to do is deselect this stage if you're not going to use those M drive motors. To date, I don't know anybody that's actually set those up. I'm the only one. And again, the purpose of those was I was doing some automatic antenna measurements. So I made up a rotor that the software can drive that can rotate the antenna vertically as well as horizontally and do a full sweep on it. You can get some 3D graphs off of it. If you're not doing any of that, you're going to have to shut this off. There's also the setting for the transfer relay and of course the primary port to communicate with the VNA. So I'd like to go over one of the last changes that I made to this software. Here I have my homemade Beatty standard. Again, this transmission line is just an air line, but it has a step in it. And that step feature gives me 25 ohms, so it goes from 50 to 25 back to 50 ohms, and it's about 70 millimeters long. If you spend any time in the group I/O sections, the TDR stuff comes up from time to time. There was actually a recent post that was talking about the original Nano VNA. I think they were running that at 1.5 gigahertz. Let me just bring it up here so you can see this is in the Nano VNA group. If I have set the stimulus start and stop to 50 kilohertz and 1.5 gigahertz, the transform maximum length is shown as 19.36 meters. If I set the sweep to 401 points, what resolution and accuracy can I expect, provided that I have the velocity factor entered correctly? So he's got this equation here of 1936 millimeters divided by 401 is equal to just over 4.8 millimeters. It's kind of interesting as you read through the comments here, nobody corrects him. Of course, I've gone over this before. I actually had one ham operator who was explaining to me that if he took the number of data points from, I don't know, 400 down to like 10 or something, it was so fast that it was actually causing my software to crash. But the whole reason that he did this is he was basically saying that with a lower number of sample points, he could increase the resolution. Yeah, again, true story. So I've made videos before on this where I talk about the number of data points that you collect defines the length that you can measure. It has nothing to do with the resolution. A good rule of thumb is basically 150 millimeters divided by the span in gigahertz is equal to the resolution. So for the light VNA, for example, this is rated for roughly 6 gigahertz. So if we took 150 millimeters, divide that by 6, that's equal to 25 millimeters. That's the resolution that this is capable of measuring. So in this post where he's talking about trying to measure 4.8 millimeters, yeah, no, it doesn't work like that. You'd have to have a much, much faster VNA, far exceeding what this light VNA can do. So hopefully that's clear. I'm sure it's not because people don't really watch these videos. So let's go ahead and we're going to turn on our light VNA. And I'm going to select link. And I'm going to select sweep. And you can see the VNA shows that it's in the USB mode now. And I'm going to set our start frequency to 50 kilohertz. And I'm going to set our stop frequency to 6 gigahertz. One of the common problems that I run into is, hopefully it's just in the United States, people don't understand the metric system. So they'll substitute a lowercase m for an uppercase m, not realizing that a lowercase m actually has a meaning to the metric system. So they'll put in like 140 small case m, thinking that's the 2 meter band, and it's not. You're talking 0.14 hertz, not 140 megahertz. So what we're going to do here is put the stop frequency to 6 gigahertz, or 6G. Again, we don't have anything attached to our VNA right now. What I'm going to do is just run through a calibration, and we'll be using the standards that were supplied with the light VNA. Again, there is a difference, and that's that I don't use the load that was supplied with the kit. Instead, I'm using a part that was provided by Mini Circuits. Again, I purchased several of these in a lot, and I used a set of metrology grade standards from Agilent, and I sorted these by return loss. This isn't the best one that I found out of the lot, but it's the second best one, and I'm using that with these low-cost VNAs. Again, if we look at the setup diagnostic page and we go to calibration terms, you can see I'm using this custom ideal standards. For a lot of these tests that I've shown, I find that using the ideal model is adequate. Let's go back to the main page, and now we'll select 2-port cal, and we're going to select new. And again, we'll be installing the short. Now normally I'd use torque wrenches on this. Again, just for this demonstration, we're not going to be doing that. You'll notice that my load is a little bit different in that I've soldered on this end cap. This allows me to hold all these parts with a wrench, and I can keep that center pin from turning while I'm torquing down this device. So let's go ahead and we'll select OK. And now we install the open. Again, we select OK. And again, we'll be using our load from Mini Circuits. And then we'll just attach our through. And I'm going to go to calibration. And This is going to be 50K to 6 gig, 1 port SoltCal. So now the system has been calibrated. So again, I have our Beatty standard out. What I'm going to do is attach this to port 1, like so. And here I have another mini circuits load. This is identical to our standard, except this is one of my rejects. And we're going to attach this to the other end of our Beatty standard, like so. So you'll notice that instead of seeing a nice little dot in the center of the Smith chart, we get this huge mess here. So if we go to impedance rectangular and we plot what that looks like, you'll notice here at 50 kilohertz, it's pretty much 50 ohms. But you'll notice as we move up in frequency, it's very unstable. The impedance goes all the way up to 220 ohms or so, and it's as low as 14. So having the Beatty standard between our load that we're trying to measure and our reference plane has really messed up this measurement. Again, if this were just a piece of coax and we were using good quality connectors, we'd be able to measure this without any problems at all. Again, its resistor has very low reflection, but if we introduce a mismatch like this, can we still measure what this load is? So I'm going to show you how that's done. So we're going to see if we can use this time domain to correct for this. So we've got the switch up here, it's called TDR or TDT. If I right click on this and we hit description and tip, you'll see we've got two different modes. One is reflection or TDR, the other one is transmission. One of the last videos that I made was showing the eye diagram feature of the software. Of course there we're using the through mode. In this case we're looking at S11 or the reflected signal, so we're using TDR. So looking at the TDR signal, we're just going to select the step mode. You'll notice that again we start off at very close to 50 ohms. It then drops to about 25 ohms, and then when it steps back up to 50 ohms, and it remains that way for the rest of the sweep. Again, we're looking at distance in meters right now, so this is 10 meters out. I can zoom into this area. Let's go ahead and we'll select show markers. You can see that currently it's showing two different peaks were found, and the distance between these peaks is 71.22 millimeters, which again is very close to our 70 millimeters. Again, this is a homemade standard. It's not a metrology grade part. The other thing too, if we go back to main, you'll notice that the velocity factor is set to 1.0. Again, that would be for our airline. So fairly close to what the actual part is. I think every time I've shown this standard on video, we always get around that 71 millimeter number. So what we can do with this now is select manual markers. And now you'll notice I can move these around freely. Now what I can do is select a gate type. So what this gate does, let's just go ahead and select the description and tip. So I have a bandpass mode, which removes all the response outside of the gate, or I can select notch, which removes all the response inside of the gate window. So I can move these cursors to make a gate window where I want to cancel this out or zero it out per se. And the way we do that is we select the gate function, and now we can select gating filter setup, and here we can display the raw data, and you can see it's much larger. Now again, that's not actually zeroing the data, this is running it through a filter. Let me go back to the main plot. Again, if we want to change the window size, we can just drag our cursors out here a little bit. Let's go ahead and shrink this back down, and then let's look at this in the frequency domain. So the yellow trace now is our new corrected value versus our red, which is the original data. So you can see that we're now very close to our 50 ohms. It's still got a little bit of disturbance to it. Let's go back to advanced and let's widen this thing up a little bit. And now let's go to gating filter again. And now let's change our filter width to minimum. You can see we've really reduced that noise. Now let's go back to the main screen. And you can see we've really squished this signal down. So again, the whole idea of using this gating function is to try to remove these disturbances. Again, we can also change the window type to only look at the area of interest. So if I were to move these cursors, say out here, and then I select bandpass mode, and I look at our gating, you can see Again, this is going to attempt to step on everything outside of the window area. So again, let's just give it the minimum filter, and we'll go back to the main screen. And again, this is our improved area versus our original. Now again, this software has had gating for quite some time. What had happened is I recently watched a video from Copper Mountain Tech. Of course, they produce VNAs, and they went over this time gating feature, and they talked about how they were doing this windowing function. And I realized what I was doing was physically zeroing out this data. Again, you can do that, but it causes a disturbance when you run the FFT across it. So while it definitely made an improvement in the measurement, it was also causing these additional disturbances. So I changed my software to add this filtering instead of this aggressive zeroing. If you decide you want to try this software, again, do it at your own risk. Again, I never intended this software to be used by the general ham operator to measure VSWR of their antennas. That's certainly not the intent of it. It's really geared more for the EE who's starting to learn about RF, and maybe they're wanting to experiment with it. So it's got a lot more features than what the ham radio operators are going to use. I'd highly recommend, if you are a ham operator and really that's all you're looking for, stick with one of the open source programs, and I think you'll be a lot better off. Again, I'm offering the software free of charge. So if you run into problems with it, don't feel you're entitled to my time to try to make corrections or additions to the software for you. Again, if I start doing that, I'm going to start charging for the software. So again, don't view it as a product. It's not. It's just my own software for my own personal use, and I've made it available for people that want to try to use it. Well, that's going to be it for now. Till the next video, we'll see you then. Later.